Hi everyone, I'm Andi, software engineer from Memgraph, and in this short video I will introduce you to the new Memgraph feature called high availability. What is even high availability? Well, high availability is considered a characteristic of the system which allows databases to uninterruptedly service applications requests. Memgraph's high availability comes on all operating systems for which Memgraph regularly provides support for, and it is available with the enterprise license. Our distributed architecture is based upon the shared nothing architecture, where all nodes are isolated from each other, don't share resources, and are hence self-sufficient. Here is how it works. Our cluster distinguishes three types of instances. The main instance is the only writable instance, and since our replication is of type primary replica, at any point there can only be one active main instance. Replicas contain all the same replicated data as main, but they can only respond to read queries. In the context of high availability, replicas can get promoted to main. There are two types of replicas we have, sync and async. Sync replica ensures consistency and partition tolerance, but not availability, since main has to wait for replicas to commit. Async replicas, on the other hand, ensure availability and partition tolerance, but not consistency, since main isn't waiting for replicas to commit. Together, main and replicas form data instances. There isn't a strict number of replicas you should have in your system, but the larger number, the larger replication factor, and the bigger chance that some replica will be able to take over once the current main gets down. Now that we have talked about data instances, let's move to coordinator instances. In our implementation, coordinator instances form raft cluster. In every raft cluster, there is one instance behaving as leader and other instances behaving as followers. Leader is maintaining active connections to data instances, and leader's most important job is to reliably select the most up-to-date replica for promotion once the current main gets down. Leader is using remote procedure call communication for that. So for example, when leader wants to promote sync replica to main, it sends info about other two instances the new main should get connected with. Followers, on the other hand, don't maintain any connections to data instances, but instead they are replicating every action leader does on cluster in its own replicated log, as specified in the Raft protocol. The Raft protocol also specifies that as long as there is a majority of nodes alive, the cluster can make progress. That means that as long as there is a majority of coordinators alive in our example, the failover operation of choosing new replica to become main can be performed. Because of that, we always advise users to select odd number of coordinators in a cluster. For example, here we chose 3 coordinator instances in order to tolerate 1 coordinator failure. For the end, let's just briefly mention that instead of implementing our version of Raft protocol, we decided to rely on new Raft, which is industry-proven Raft implementation and whose biggest advantage is the lightweight capability of integration into the existing codebase. Thanks for joining us today. In this video, we explored different types of instances within a cluster and how they work together to ensure high availability. In the next video, we'll show you how to actually connect these instances and set up your Memgraph cluster. We'll guide you through the entire configuration process to help you get started. Stay tuned.